So the next example we're going to look at is example 6. And you're going to note the change because of what I've highlighted. In all of the other problems, we were only ever dealing with singular x's. You can see that up above here, here, single thetas, etc. So the change that we're looking for in part 2 of the notes is that now we're going to change to a 2x or a 3x. As a review of the concepts, if we go back, and I believe we had 2 students stand at the board to illustrate this with cosine, but if we look at sine between 0 and 2 pi, when there's a singular x, we only have one repetition. Put a 1 in front for placeholder. We have one repetition of the sine curve. However, when we put a 2 in front, that changes and it gives us 2 repetitions in the same x space. 2 repetitions of the pattern. So if you remember, we said, well, what's the new period? Well, the old period was 2 pi in length, and then we divide it by the coefficient. That came from the graphing unit, which is now the new period is between 0 and pi. Keeping that idea in mind, we are going to isolate the trig term involving the 2x. So when I do that, I get tangent of 2x is equal to negative root 3 over 3. I'm then going to pretend as though this isn't a 2, but it's just a 1. And I'm going to think out on the unit circle where tangent of x is equal to negative root 3 over 3. In the previous units when we've done this, we would unrationalize. So when I come over here, I would move the root 3 back to the bottom, which gives me the negative 1 over root 3. I then would re-put in divide by 2. And I know that tangent is a ratio of y over x. So I'm going to ask myself, where on the unit circle do I have a y value that is 1/2 and an x value that is positive root 3 over 2? That's going to occur with opposite signs at these 2 locations, closest to the x-axis. So in radians, thinking out this statement of tangent of x, my answer is going to be 5 pi over 6 and 11 pi over 6. Okay? That's step 1. Step 2 is to say, well, if we think back to here, between 0 and 2 pi, I'm going to have 2 repetitions. So I need to create 2 more values. To do that, I take each one of these. So I'm going to take 5 pi over 6, and I'm going to add 2 pi to it. And I'm going to take 11 pi over 6, and I'm going to add 2 pi to it. 2 pi is 12 over 6, so this becomes 17 pi over 6, and this becomes 23 pi over 6. Now, the issue we have at this point, and this is why we can't stop here, is that the solutions have to be between 0 and 2 pi. Obviously, these 2 are outside of that realm. So we're then going to solve the equation of 2x set equal to each one of these. In other words, I'm going to divide by 2, divide by 2, divide by 2, and divide by 2. When I divide by 2, I get 5 pi over 12, 11 pi over 12, 17 pi over 12, and 23 pi over 12. All of these, if you converted them to decimals, would be less than 2. This is a bracket. These are my final answers of x. Now, I'm going to skip around a little bit. I'm going to go over here to example 9. The procedure is very simple. Notice I have my trig ratio, but now I have a 3 in front. So I'm going to need 3 repetitions. I pretend that my trig equation just says tangent of x is equal to negative root 3 over 3. I then unrationalize and get the 1 over root 3. Divide everybody back by 2 in order to convert to unit circle values. So I'm looking for where y is 1/2 and x is root 3 over 2. I can kind of feel some of your minds spinning about why I chose 2 values. This negative can go up top or it can go in the bottom. So the other option for this would be 1/2 over negative root 3 over 2, which is what generates that secondary point from the last example. So since this is the same, we're going to use 5 pi over 6, 11 pi over 6, We're then going to add 2 pi to all of those. So I'm going to add 12, which is 17 pi over 6. Add 2 pi to this, which is 23 pi over 6. Then I'm going to take this revolution, and I'm going to add 2 more pi to it. So this is 17 plus 12, which is 29 pi over 6. 23 plus 12, which is 35 pi over 6. Remember, these are initial solutions of which the last 4 are outside of 2 pi. So now I'm going to go back and I'm going to divide everybody by 3. Okay, mathematically, pretty simple part. 5 pi over 18, 11 pi over 18, 17 pi over 18 less than 1, 23 pi over 18, 29 pi over 18, and 35 pi over 18. And now I'm done. In the same unit that we talked about repeating, we also talked about taking sign and moving it left and right. Here's an example of that with 7. Notice that what I'm dealing with isn't just the singular x, it's an x plus pi over 3. In general, you should remember that this is taking sign and moving it to the left because it's opposite of the sign. We are going to pretend that this part on the left, this trig term, just says sine of x equals 1/2. So I want to know where the y value of the unit circle is going to be 1/2. That's going to occur at 2 places, here and here. So I'm dealing with x. I can say pi over 6, and I can say 5 pi over 6. These are my initial positions that answer this as though it was just sine x. I'm going to take what's in the parentheses and set it equal to pi over 6 and 5 pi over 6. Solve each equation, minus pi over 3. So this becomes 1/6 minus 2/6, which is negative pi over 6. That's one solution. The next solution, minus pi over 3, minus pi over 3. Mathematically, 5/6 minus, this is times 2, gives me 3 pi over 6, or negative pi over 2. These are my final answers. One issue with this. We were told that this has to exist between 0 and 2 pi. Do either of these fall in this interval? No. So if I look at negative pi over 6, which is going to be right here, what is the coterminal angle that falls in? 11 pi over 6. What about negative pi over 2? That's the same thing as 3 pi over 2. These are my answers. I can't have negatives. Moving over to number 8. You should have already had number 10 finished in your notes. Number 8 is actually doing the work ahead of time in order to get down to a quadratic formula. So let's talk about that. The first thing that's going to happen is that you're going to notice that there is no way for this equation to factor. And if you don't recognize it right away, you can rewrite it without the signs. S squared minus 3s minus 1 will never ever factor. There's nothing you can multiply to give you 1 that's going to add to 3. That's what tells us we go to quadratic formula. Everything is on one side equal to 0. A is 1, this is a 1, B is negative 3, C is negative 1. I then take these values and put them into the quadratic formula and simplify. Now, once I simplify, I end up with the sine of x, or in this case the sine of theta, is equal to 3 plus or minus root 13, all of which is over 2. Looking back at number 10, you need to see that this is going to get split into 2 separate equations to solve. For prosperity's sake, we're going to put this into the calculator. So let's start with the first one. I'm going to put in 3 plus the square root of 13. Hit enter. That's my numerator. I'm going to divide it by 2. I now have a decimal. I'm going to take the sine inverse of the same answer. So I'm taking the inverse of this, and I get error. The reason I'm getting an error is because when I went back up, if you notice, I have 3.3. 3.3 will never ever work to be a sine value. The opposite side should always be smaller than the hypotenuse. If you didn't recognize that, that's why you're getting the error. Now let's try the other side. Clear this out. Let's come back down. So I'm going to do 3 minus the square root of 13. And then I'm going to divide by 2. And now I'm going to do inverse sine of that same answer. This is a decimal, shouldn't have an issue. And I get negative 17.6. Negative 17.6 degrees. Negative 17.6 is not in the interval from 0 to 360. So what I want to do is I want to calculate this angle in red. Okay, so I'm going to say that theta is equal to, and in my calculator I can do 360 minus 17.6, and I'm going to get 342.4. Okay, and now this is where your understanding of sine and cosine on the unit circle is essential. Sine is the y value. Where else, in which quadrant, do I have a y value that would be the same as this point right here? Oh, well, it would exist on this side. This is going to be 17.6 degrees. The other angle is going to be this value here. So the other side of this is going to be 180 plus 17.6, or 197.6 degrees. Because this had no solution, this has 2 solutions, my final answer is going to be these 2.